Hello students, good morning. Today we are going to next session, that is the fifth session of your chapter Quadrilaterals. We already completed 4 sessions, right? So in this session we are going to discuss some properties that is related to the rectangle and rhombus. Okay, so take the first one, that is rectangle. So rectangle is a quadrilateral. Rectangle is a quadrilateral in that opposite sides are equal and parallel, right? As we already discussed in the previous class, a rectangle is a parallelogram. Rectangle is a parallelogram, right? So ABCD is a here. ABCD is a rectangle. ABCD is a rectangle. Now, what are the properties of this rectangle? First one, as we all know that the rectangle is a parallelogram. The rectangle is parallelogram. So, the properties of parallelogram is similar to the rectangle, right? In that first property, in rectangle, opposite sides are equal and parallel. Opposite sides are equal and parallel. Opposite sides are equal and parallel. Equal and parallel. Okay, this is the first property. So what are the two equal sides here? AB. AB is opposite to DC. The opposite sides are equal and parallel means the same sides are parallel to each other. This is the one pair. Next, one more, second pair is AD is equal to BC. AD is equal to BC. AD is parallel to BC. So the first property is opposite sides are equal and parallel. Second one, each angle in the rectangle is 90 degree. It means each angle is right angle. Each angle in the rectangle is right angle. Right angle. For example, the 4 angles are there, no? All the 4 angles are measuring 90 degrees. So angle A is equal to, angle B is equal to, angle C equal to, angle D. All the 4 angles equally measuring, that is equal to 90 degree. This is the second property. Next, third property. The adjacent sides of the rectangles are not equal. The adjacent sides of the rectangle are not equal. So adjacent sides are not equal. Adjacent sides are not equal. So what are the two adjacent sides here? AD, we already know in the quadrilateral there are 4 pair of adjacent sides are there. So the side AD, which is not equal to the another side BC. So AD is not equal to AB. AD is not equal to AB, right? This is the one example in that the adjacent sides are not equal. Next one. When I draw the diagonals in the rectangle, the length of the diagonals are equal. Diagonals are equal in length. So the length of the diagonals are equal in the rectangle. So what are the two diagonals here? AC is equal to BD. First diagonal AC is equal to the second diagonal BD. Next, fifth point. A fifth property of the rectangle is each diagonal of the rectangle divides the rectangle into 2 congruent triangles. Here, if I take AC is a diagonal, it divides the rectangle into 2 congruent triangles. For example, AC is the diagonal, no? It divides the whole rectangle into two equal triangles. The triangle ABC is congruent to the triangle ADC. Similarly, one more diagonal is there. BD is the second diagonal, no? Again that diagonal divides the rectangle into two congruent triangles. So what are the two triangles? Triangle ABD and triangle BCD. So diagonals divides rectangle. Each diagonal divides the rectangle into two congruent triangles. Right? So what are the two congruent triangles here? If I take AC as a diagonal, right? So that diagonal divides the rectangle into two congruent triangles. What are the two congruent triangles? Triangle ABC is congruent to the triangle, second triangle ADC. Next, second diagonal. Take the second diagonal BD. That BD diagonal divides the whole triangle into again two congruent triangles, and that two congruent triangles are ABD. Triangle ABD is congruent to the triangle BCD. Right? Next one. Sixth property of the rectangle. What is that sixth property? When two diagonals intersect at one point, the diagonals of the rectangle bisect each other. It means here AC and BD are the two diagonals. They meet at one particular point O. When it intersect, the whole diagonal divides into two equal parts. It means bisected into two equal parts. So what are the two equal parts? Diagonals bisect each other. The diagonals bisect each other. It means in first diagonal OC is equal to OA is equal to OC, and second one OB is equal to OD. Okay. Next, the diagonals, when the diagonals intersect, it will not form a right angle. So this is the last property of the rectangle. Okay, so these are the some basic properties related to the rectangle. What is that first property? Opposite sides are equal and parallel. Second one, each angle in the rectangle is 90 degree. Third one, adjacent sides are not equal. Next, fourth one, diagonals are equal in length. Next, fifth one, each diagonal divides the rectangle into two congruent triangles. And the last one is diagonals bisect each other. Okay. Next, take one theorem, that is the diagonals of the rectangle bisect each other. So I already know the properties of the rectangle. So first theorem is diagonals of rectangle bisect each other. Diagonals of rectangle bisect each other. This is the statement of the given theorem. Okay. So first draw one rectangle. Take one rectangle ABCD. ABCD is a rectangle. AC and BD are the two diagonals, and these two diagonals are meet at one particular point, that is O, right? So what you have to prove here? First write the given part. ABCD is a rectangle. ABCD is a rectangle, right? What you have to prove? We need to prove that diagonals of the rectangle bisect each other. Diagonals of the rectangle bisect each other. It means the length of OA is equal to OC, and OB is equal to OD, right? Next, proof. When two diagonals, we already discussed in the properties of the rectangle, when two diagonals intersect at one particular point, it forms four triangles in the particular rectangle, right? So you can take any two triangles which is exactly in the opposite sides. So first consider in triangle AOB, in triangle AOB and triangle COD, triangle AOB and triangle COD. AB is equal to CD. How they are equal? Because these two are the opposite sides of the rectangle. Opposite sides are equal in rectangle means, so AB is equal to CD. Opposite sides of rectangle. Opposite sides of rectangle. If AB is equal to CD means, again the opposite sides are parallel in rectangle. So if these two sides are parallel, it forms alternate angles, right? So angle OAB, angle OAB is equal to angle OCD, angle OCD. These two are alternate angles. Alternate angles because AB is parallel to CD. AB is parallel to CD. One more pair of alternate angles are there here. Angle OBA, angle OBA is equal to angle ODC. The same reason, that is alternate angles, because AB is perpendicular to CD, right? So therefore a triangle AOB is congruent to triangle COD. Triangle AOB is congruent to triangle COD by using the congruence property, that is ASA. By using angle side angle congruence criteria, the two triangles are congruent to each other. If two triangles are congruent, then their remaining all sides and angles are equal. So OA is equal to OC. Next, OB is equal to OD by CPCT, corresponding parts of the congruent triangles. OA is equal to OC and OB is equal to OD. Here OA is a half of the diagonal AC, half of the diagonal AC, whereas OB is a half of the diagonal BD. So each diagonals are equal. AC is equal to BD. Hence we proved that the diagonals of the rectangle bisect each other. Okay students, next move to the next quadrilateral, that is the rhombus. So rhombus is also one type of the parallelogram. Rhombus is a one type of the parallelogram, right? Here ABCD is a ABCD is a rhombus. Now what are the properties of rhombus? In rhombus, all four sides are equal. All the sides of the rhombus are equal. Here four sides are there, no? The length of all these four sides are equal. It means the length of AB is equal to BC is equal to CD is equal to DA. The length of all four sides of the rhombus are equal. Okay, this is the first property. Next one, opposite sides of the rhombus are parallel. The opposite sides are parallel. Opposite sides are parallel. Hence we are considering a rhombus as a parallelogram. So what are the two pair of opposite sides here? AB is parallel to CD. Side AB is parallel to CD. Next one, the side BC is parallel to AD. The opposite sides are parallel. Next, opposite angles of the rhombus are equal. Opposite angles are equal. So what are the two pair of opposite angles here? Angle A is equal to angle C. Angle A is equal to angle C and angle B is equal to angle D. So opposite angles of the rhombus are equal. Next, when two diagonals intersect in the rhombus or in quadrilateral, we can draw maximum two diagonals. When these two diagonals intersect at one point, they are equally bisected. It means the diagonals bisect each other at right angle. Diagonals are bisect each other at right angle. It means the diagonal AC and BD, when these two diagonals are intersect at point O, the length of OA is equal to OC. The diagonal is bisected. It means it divides into two equal parts. So OA is equal to OC and OB is equal to OD. Diagonals are bisect each other. Next one, the two diagonals of the rhombus bisect at right angle. Diagonals bisect at right angle. For example, here AC and BD are the two diagonals. When these two diagonals are bisect or intersect at right angles, it means here it forms perpendicular. Angle CO or the line segment CO is perpendicular to BD. AO is perpendicular to the same diagonal BD. So like that, the diagonals are intersect perpendicularly, right, or right angle. Next one, as we already discussed in the previous one, the diagonals of the rhombus divides the rhombus into two congruent triangles. Each diagonal divides rhombus into two congruent triangles. If I take AC as a diagonal, it divides the rhombus into two equal parts or two equal triangles, and that two triangles are congruent to each other. It means the triangle ABC is congruent to triangle BCD. when we are considering AC as a diagonal. If you take BD as a diagonal, so what are the two congruent triangles? Triangle BCD is congruent to triangle BCD is congruent to triangle ABD. Okay, and the next property is when these two diagonals, diagonal AC and BD, intersect each other, it forms four congruent triangles in the rhombus. So two diagonals form four congruent triangles. When two diagonals are intersect, it forms four triangles, and all four triangles are congruent to each other. It means triangle AOB is congruent to triangle BOC is congruent to triangle COD is congruent to the triangle DOA. All the four triangles formed by the bisection of or intersection of two diagonals, all these four triangles are congruent to each other. So these are the some basic properties of the rhombus. Okay, next we will discuss some theorems which is based on the properties. In that first one, the diagonals of the rhombus bisect each other. The diagonals of the rhombus bisect each other at right angle. The diagonals of rhombus bisect each other at right angle. Right angle means 90 degree. At right angle. So this is the statement of the theorem, right? So the diagonals of the rhombus bisect each other at right angle. So take one, draw one rhombus. Here A, B, C, D. A, B, C and D is the rhombus. What are the two diagonals here? AC and BD are the two diagonals. When these two diagonals are bisect or intersects, it will forms at 90 degree at the point of intersection, right? So first write the given part. Given is ABCD is a rhombus. ABCD is a rhombus. Next, they are already given the diagonals are bisected. Diagonals are bisected means OA is equal to OC and OB is equal to OD. OB is equal to OD. Right? Next, what you have to prove here? You need to prove that any one angle, you can take any one angle, either angle AOB is equal to 90 degree or angle BOC is equal to 90 degree. Need to prove any one angle formed at the point of intersection is 90 degree. So angle AOB is equal to 90 degree. Okay. Next, proof. In the rhombus, adjacent sides is also equal, no? Here we are considering two adjacent triangles. In triangle, AC and BD are the two diagonals. They will meet at one particular point O and it forms four triangles and all four triangles are congruent to each other. In that we are considering the any two adjacent triangles. So in triangle AOB and triangle AOD. Consider these two triangles, triangle AOB and triangle AOD. AB is equal to, in which AB is equal to AD. Reason, these are the sides of the rhombus. It means all four sides are equal in rhombus, right? So adjacent sides are equal. Next, OB is equal, OA is equal to OA. OA is the common side for both two triangles. Next one, OB is equal to OD. OB is equal to OD. This is already given in the statement. The diagonals are bisects, right? Therefore, the triangle AOB is congruent to the triangle AOD by using the congruence criteria. Yes. Here we are considering two triangles. In that, AB is equal to AD. These two are the adjacent sides of the rhombus. OA and OA are the common side for these two triangles. Next, OB is equal to OD. The bisections are bisected part of the diagonal, right? Therefore, the given two triangles are congruent to each other. Once we proved that the two triangles are congruent, the remaining parts are equal. Okay. So, angle AOB is equal to angle AOB is equal to angle AOD. Angle AOD by using CPCT, corresponding parts of congruent triangles, right? The same two angles, angle AOB plus angle AOD equal to 180 degree. Reason, these two angles will form a linear pair. Just observe these two angles, angle AOB plus angle AOD, sum of these two angles are adjacent angles, and by adding these two angles we will get supplementary angle. The sum of these two angles is equal to 180 degree. Therefore, angle AOB plus angle AOD is equal to 180 degree. Reason, linear pair. We already proved that these two angles are equal. So, in that, consider any one angle. Either you can take AOB or AOD. Angle AOB plus angle AOB is equal to 180 degree. Angle AOB plus angle AOB means 2 times of angle AOB is equal to 180 degree, right? So, angle AOB is equal to 180 divided by 2, that is equal to angle AOB is equal to 90 degree. It means we proved that the angle when the diagonals are intersect, it forms a 90 degree. So, this is the proof of the given statement. So, what is that given statement? The diagonals of the rhombus bisect each other at right angle. We proved here the diagonals when bisect each other, it forms right angle. Okay. So, angle AOB, if angle AOB is 90 degree means angle AOD is also 90 degree, and remaining these two angles is also 90 degree and 90 degree. This is the theorem which is based on the bisection of the diagonals of the rhombus. Next theorem is the diagonals of the rhombus, form 4 congruent triangles. So, we already discussed in the properties of rhombus. When two diagonals of the rhombus intersect each other at one particular point, that point divides the rhombus, or two diagonals divides the rhombus into 4 triangles, and all the 4 triangles are congruent to each other. Okay. So, we need to prove the given statement here. For that, consider one rhombus. Here A, B, C and D is a rhombus. AC and BD are the two diagonals of the rhombus. These two diagonals are intersect at point O. Okay. So all the four sides of the rhombus are equal and the diagonals are bisect each other, right? So write the given part. The diagonals of the rhombus forms four congruent triangles. So here ABCD is rhombus. ABCD is a rhombus in that the diagonals are bisected. It means OA is equal to OC and OB is equal to OD. OB is equal to OD. What you have to prove here? The four triangles formed by the diagonals are congruent. You need to prove that the triangle AOB is congruent to triangle BOC is congruent to triangle COD is congruent to triangle DOA. The four triangles of the rhombus are congruent to each other. Okay. Proof. First, consider any two adjacent triangles. In triangle, here I am considering the two adjacent triangles, triangle AOB and triangle BOC. Triangle AOB and triangle BOC. In that AB is equal to BC. AB is equal to BC. These are the adjacent sides of rhombus. So all the four sides are equal in rhombus, right? Next, OB is equal to, in these two triangles, OB is the common side. OB is equal to OB, which is common for both two triangles. Next one, OA is equal to OC. OA is equal to OC. It is given in the statement. Given. The diagonals are bisects each other. Therefore, triangle AOB is congruent to triangle BOC by using the congruence criteria SSS. Consider this one as equation 1. For first proof or for first equation, we are considering these two triangles. Now, next two adjacent triangles, we need to consider the two adjacent triangles. They are triangle in triangle BOC, in triangle BOC and triangle COD. Triangle COD. In that BC is equal to CD. BC is equal to CD because these two are the adjacent sides of rhombus. Okay. Next, OC is the common side for these two triangles. So OC is equal to OC, that is common. Next one, the diagonals are bisected, means OB is equal to OD. OB is equal to OD. Given. Therefore, triangle BOC is congruent to triangle COD by using the same criteria SSS. Consider this equation as 2. Next one, for first proof we are considering these two adjacent triangles. For second proof or second equation we are considering the next two adjacent triangles. Next, the remaining two triangles, consider the remaining two adjacent triangles. What are the two remaining adjacent triangles? Triangle COD and triangle AOD. In triangle COD and triangle AOD. CD is equal to, the length of the side CD is equal to AD, because these two are the adjacent sides of the rhombus, adjacent sides of rhombus. Okay. Next, OD is the common side. When we are considering these two triangles, COD and DOA, OD is the common side. OD is the common side for these two triangles. So OD is equal to OD, common. Next one, here one diagonal is there. OC is equal to, AC is the diagonal, no, that diagonal is bisected, means OC is equal to OA, or OA is equal to OC. This is given. Therefore, triangle COD is congruent to the triangle AOD by using the same criteria, that is SSS congruence criteria of the triangles. Here, from equation 1, 2, 3, just observe these equations. This is equation 1. In that equation, we are proving these two triangles are congruent. In second equation, we are proving the next two adjacent triangles are congruent. In the third equation, we are proving these two triangles are congruent. So, this equation is considered as a 3 from equation 1, 2 and 3. Equation 1, 2 and 3, equal things are equal to one another. We already know, right? So here, just observe the first equation. Triangle AOB is congruent to BOC. That BOC is congruent to COD. The same triangle is congruent to AOD, right? So equal things are equal means the all four triangles are congruent to each other. Therefore, triangle AOB is congruent to triangle BOC, which is congruent to the triangle COD, and that triangle is congruent to the last triangle, that is DOA. Hence, we proved the given statement. What is that given statement? The diagonals of the rhombus form four congruent triangles. Here, the four triangles are congruent to each other. Okay. So, this is the proof of the given statement. In the next class, we will discuss some properties which is based on square, next one trapezium, kite. Okay. Be happy. Have a nice day. Thank you.